Welcome to one more video lecture. In this video lecture we are going to start with one of the type of the motion. The flowchart of the syllabus is like this. In 11th standard you might have been studied with the motion of an object in a straight line, that is straight line motion, in which we studied the different physical quantities in a motion: displacement, speed, velocity, acceleration, distance covered. And then in dynamics we studied about force, momentum, like that. At the same time, motion in plane, that is circular motion, some part of the circular motion we studied in the 11th class, and remaining part of the circular motion with the example of circular motion, conical pendulum, motion of a rider in a death well, motion in a vertical circular motion that we studied earlier. In rotational dynamics we also studied about the rotational motion. In rotational motion we think of the moment of inertia, the kinetic energy, torque, like that. The kinematics of rotation as well as the dynamics of the rotation that we studied. Now hereafter we will think of one more important type of motion. Again I will start with what do you mean with motion. The change in the position of an object with respect to surrounding and with respect to time is called as motion. The different types of the motion are the rectilinear straight line motion, or circular or rotational motion, and third is the oscillatory motion, and fourth one is the random motion. Depending upon how the position of the object is located in a motion, motion is also divided into three types: one-dimensional motion, a motion of an object in which only one coordinate changes with time, that is one-dimensional motion. A rectilinear motion along one of the axes is the example of rectilinear motion in one dimension. If the position of an object in motion is located by two coordinates simultaneously, and if the motion happens to be in a plane, then it is two-dimensional motion. Circular motion, projectile motion are the two-dimensional motions. And third is oscillatory motion. We are thinking of oscillatory motion. In day-to-day life we come across many examples of the oscillatory motion. So many examples. Motion of a simple pendulum is an oscillatory motion along a straight line. Motion of a needle of a sieving machine is an oscillatory motion along a straight line. And motion of the wipers on the glass window of a car is an oscillatory motion in a car or a path. The to and fro motion of an object is an oscillatory motion. And oscillatory motion is a periodic motion. What periodic motion is? The motion of an object along a given path which repeats itself after a given interval of a time is called as a periodic motion. A motion which repeats after regular interval of a time in a given path is called as the periodic motion. One example of periodic motion that we studied earlier is uniform circular motion. Oscillatory motion is also a periodic motion. Every circular motion is a periodic motion. But every periodic motion need not necessarily but is a circular motion. Oscillatory motion is periodic but it is not circular. How it is so? We will see hereafter. विद्यार्थी मित्रांनो, आपण मोशनचा अभ्यास शालेय जीवनापासून करत आलो. वस्तू जेव्हा एका ठिकाणाहून दुसऱ्या ठिकाणी जाते तेव्हा ती मोशन मध्ये आहे असं म्हणतो. मोशनचं आपण वर्गीकरण केलेलं आहे. सरळ रेषेतली मोशन, एकरेषीय मोशन, वर्तुळाकार पाथ मध्ये होणारी मोशन, परिवलनीय गती आणि तिसरा प्रकार आपण कंपन गती सांगितलेली आहे आणि चौथा प्रकार सांगितला यादृच्छिक गती, रॅन्डम मोशन. मोशनचे आपण परत असे भाग केलेत: 1 डायमेन्शनल मोशन, 2 डायमेन्शनल मोशन, 3 डायमेन्शनल मोशन. सर्क्युलर मोशन, प्रोजेक्टाइल मोशन ही 2 डायमेन्शनल मोशन आहेत. आणि आपल्याला असं माहिती आहे की जी मोशन परत परत एका विशिष्ट वेळेनंतर घडून येते त्याला आपण पिरियॉडिक मोशन असं म्हणत असतो. युनिफॉर्म सर्क्युलर मोशन हे पिरियॉडिक मोशनचं उत्कृष्ट उदाहरण आहे. सगळे युनिफॉर्म सर्क्युलर मोशन पिरियॉडिक आहेत, पण सगळे पिरियॉडिक मोशन युनिफॉर्म सर्क्युलर मोशन नाही आहेत, कारण ऑसिलेटरी मोशन ही पिरियॉडिक मोशन आहे. आपल्याला जास्त विचार करायचा आहे तो ऑसिलेटरी मोशनचा. ऑसिलेटरी मोशन इज द टू अँड फ्रो मोशन ऑफ एन ऑब्जेक्ट. If object is moving along a straight line or along a curved path and its path is repeated after regular interval of a time, then the motion is oscillatory motion. Before to start with oscillatory motion, again I will come back to uniform circular motion, which is a periodic motion. What we said about uniform circular motion? Uniform circular motion, it is a motion of an object along the circumference of a circle. It is uniform because time required by the particle to complete one revolution, that is the period of revolution, is same for every revolution. Therefore, the motion of an object along the circumference of a circle with constant speed is uniform circular motion. It is periodic because it repeats after regular interval of a time. In this periodic motion, what the thing used to happen, the velocity of the particle in uniform circular motion at every instant of time is along the tangent. Therefore, it is having constant magnitude, but the direction of velocity is changing continuously. Because of change in the direction of velocity in uniform circular motion, it has acceleration, and we proved that this acceleration is along the radius and hence called as radial acceleration or centripetal acceleration. This radial acceleration or centripetal acceleration is provided by centripetal force, and this centripetal force is given by mass into radial acceleration or centripetal acceleration. This centripetal force is in the direction of this centripetal acceleration, and this centripetal acceleration is along the radius towards the center, and it is given by r into omega square, where r is the radius vector. Here I want to underline one thing here is that the force in a uniform circular motion is with a direction it can be written as minus of. The force in uniform circular motion is along the radius and towards the center. It is in the direction opposite to that of the radius vector, and this centripetal force is always changing its direction. There is continuous change in the direction of a centripetal force. Therefore, uniform circular motion is an example of periodic motion in which the force which is responsible for uniform circular motion is along the radius towards the center, and its direction continuously changes. This is a periodic motion in which the force is of constant magnitude and changing direction. This is uniform circular motion. But to and fro motion of an object is called as oscillatory motion. This in oscillatory motion, how is the force and what is its magnitude? What about the direction of the force in oscillatory motion? That is the interest of our study in this video lecture. Now we will discuss one of the example of oscillatory motion, that is oscillations of spiral spring on the table. Before to start with the discussion of the oscillations of the spiral spring, you must be aware with the fact that spiral spring is an elastic body. The spiral spring has a very important property that it always tries to maintain its original length or original size. The internal force that has been developed in the spiral spring in order to bring the spiral spring back to its original length or the original dimensions is called as the restoring force. This restoring force is such that it always tries to bring the spiral spring back to its original length. These are the things that is to be remembered very clearly while thinking of oscillations of the spiral spring. Dear friend, let us consider there is spiral spring which is kept horizontal on the table. The free end of the spiral spring is attached with some mass. Here it is a block, and when this spiral spring is kept on the table and block is on the table, and when it has its original length, in that case, there is no restoring force acting on the spiral spring because it is already at its original length, original dimension. The restoring force has to bring back to original dimension, but it is already at its original length, original dimension. Therefore, there is no restoring force acting on it, and it is said to be in equilibrium. Let that equilibrium position is represented by O. At equilibrium, there is no restoring force and it is represented by O. Thereafter, manually or mechanically, we are pulling this block so that the spirals get stretched. By stretching the spiral, we displace the block away from the equilibrium position towards the light. In that case, the length of the block has been increased. Length of the spiral spring has been increased. The spiral spring is stretched. The spiral spring is elongated. In that case, because of the natural tendency, the natural property of elasticity, the spiral spring tries to maintain its original length, and in order to do so, internal restoring force is developed in the block, and that internal restoring force developed in the block is towards equilibrium. The force is towards equilibrium, and the force has tendency to bring the block back to its original position. This restoring force has a tendency to bring the spiral spring to its original length. Therefore, direction of this restoring force is towards equilibrium, that is towards the left. And the displacement in this case measured from the equilibrium O. Therefore, the displacement X is represented by X. The displacement is represented by X. It is away from the equilibrium. Here you will see that the force is towards equilibrium. Displacement is away from the equilibrium. Force and displacement are opposite to each other. When block is at equilibrium, the restoring force is 0, the displacement is 0. When we begin to stretch the spiral, while the spiral gets elongated, the restoring force is developed in the block. It is towards equilibrium and the block is displacing away from equilibrium. The maximum displacement, it is represented by the maximum displacement is represented by plus of A. And when it has a maximum displacement, it has maximum elongation, it has maximum change, and because of that, the force developed at this position will be maximum. When displacement is maximum, the change is maximum, and tendency to bring it back to its original has maximum force, and because of that, when displacement is maximum, force is maximum. And at a given instant of time, let the block is released from the equilibrium, because of this restoring force, the block begin to move towards the equilibrium, and when it tries to come back to its equilibrium, its displacement which has been measured from the mean position goes on decreasing, and as it is approaching towards the equilibrium, it is coming towards its original length, the force also goes on decreasing. With increase in displacement, more is the elongation, more is the force. When it is released, it is moving towards the equilibrium, the displacement measured from the equilibrium it decreases, and as it is coming towards equilibrium, its force also decreasing. Therefore, with increase in force, there is more displacement. When displacement is decreasing, the force is also decreasing. When it comes to the equilibrium, force and displacement both are zero. Therefore, I will write here the force is directly proportional to the displacement. More is the displacement, more is the force. Less is the displacement, less is the force. Zero is the displacement, zero is the force. Therefore, in magnitude, force is directly proportional to displacement. Where here what you will see that force and displacement are opposite to each other. Therefore, I will write here F is directly proportional to minus x. But when you release the block from the positive extreme position, the block begin to move towards equilibrium because of restoring force, and while going towards the equilibrium position, the force and displacement both are in the same direction, and when the body is moving in the direction of a force, at that time the body gets accelerated, and because of that acceleration, the velocity goes on increasing, and ultimately when it comes to the equilibrium, it has maximum velocity. It has maximum velocity. Therefore, when block come to the equilibrium, its displacement is zero, the force is zero, but velocity is maximum, and because of that maximum velocity, because of kinetic energy attained by the block, because of the inertial tendency, the block continue to move ahead towards the left. And when it crosses the equilibrium and moving towards the left, the spiral spring gets compressed. Here there will be compression of the spiral spring. And as the block is displaced towards the left, the spiral spring gets compressed. There will be change in the length of the spiral spring. There will be change in the direction of the spiral spring. And again, because of elastic property, the spiral spring opposes to change its dimension, and internal restoring force is developed. Now this internal restoring force is to oppose the change, means it is against the compression and towards the equilibrium. Here the displacement is measured from the equilibrium, it is towards the left, and the force is towards the equilibrium, that is towards right. The force and displacement are in opposite direction. And as the block is moving against the direction of force, then there will be retardation of the block, and because of that there will be decrease in the velocity of the block, and finally the velocity at the extreme becomes zero, and here at the negative extreme the velocity reduces to zero. And when the velocity reduces to zero, the block is momentarily at rest, but at the same instant or immediate instant, because of the restoring force, the block begin to move towards the equilibrium. The block is moving in the direction of a force. Because of that, there will be increase in velocity. When it comes to equilibrium, it has maximum velocity. It will continue its motion towards the right. There will be the stretching of the spirals, again a restoring force towards equilibrium, and the velocity goes on decreasing. Finally, at the extreme velocity reduces to zero, the block comes momentarily at rest, and the restoring force again make it to move towards the equilibrium. Like that, between two extremes, the block is continuously moving. At the extreme, the restoring force make it to move towards the equilibrium, and at the equilibrium, the velocity make it to move towards the equilibrium, and the force and velocity are acting in such a way that they are not allowing the block to remain at rest either at equilibrium or at extreme, and such a motion is a oscillatory motion. It is repeated after regular interval of a time, therefore it is periodic motion. But in this periodic motion, what important is that the direction of force is always changing. How is the force? When the block is moving towards the positive extreme, the force is towards the equilibrium, towards the left. When the block is moving towards the negative extreme, the force is towards the right, towards the equilibrium. Therefore, every time, whether it is moving to positive extreme or negative extreme, every time the force is always towards a fixed point, and that fixed point is equilibrium. This is one thing. The direction of force is not constant in this case, it is changing continuously. This is the one thing. And what about the displacement? All the displacement are measured from a reference point. Here convenient reference point is the equilibrium position. Therefore all the displacement are measured from the equilibrium point. Therefore when it is moving towards the right, the displacement is positive, and when it is moving towards the left, the displacement is negative. The displacement is also changing. The force and displacement are, this displacement is always measured from, equilibrium. Now what you will see that force is towards equilibrium, displacement is measured from equilibrium, it is towards from. Therefore these two are in opposite direction. At the same time, the magnitude of the force is directly proportional to displacement. Such a type of motion which is periodic, which is oscillatory, is called as the simple harmonic motion. मित्रांनो, एक लक्षात ठेवा, जी मोशन एका विशिष्ट काळानंतर रिपीट होते त्याला आपण पिरियडिक मोशन म्हणतो. सर्क्युलर मोशन, युनिफॉर्म सर्क्युलर मोशन ही पिरियडिक मोशन आहे. आपल्याला माहित आहे घड्याळाच्या काट्याची मोशन ही पिरियडिक आहे, कारण ती एका विशिष्ट कालावधीनंतर रिपीट होते. पृथ्वीचं सूर्याभोवती फिरणं, चंद्राचं पृथ्वीभोवती फिरणं ही पिरियडिक मोशन आहे, ती विशिष्ट काळानंतर रिपीट होते. युनिफॉर्म सर्क्युलर मोशन पिरियडिक मोशनचं उदाहरण आहे. याच्यामध्ये फोर्स मॅग्निट्यूड कॉन्स्टंट आहे, डायरेक्शन कंटिन्युअसली चेंज होत जाते. पण ऑसिलेटरी मोशन जी टू अँड फ्रो मोशन आहे त्याचं एक उदाहरण पाहिलं. या उदाहरणामध्ये असं लक्षात येतं की यातला फोर्स नेहमी एका पॉइंटला फिक्स आहे, आणि तो पॉइंट म्हणजे काय, इक्विलिब्रियम आहे. आणि यातलं डिस्प्लेसमेंट इक्विलिब्रियम पासून मेजर केलं जातं. फोर्स आणि डिस्प्लेसमेंट, फोर्स हा नेहमी इक्विलिब्रियम कडे आहे, डिस्प्लेसमेंट इक्विलिब्रियम पासून आहे, म्हणून फोर्स आणि डिस्प्लेसमेंट एकमेकाच्या अपोजिट आहेत. आणि फोर्सचं मॅग्निट्यूड इतकं डेव्हलप होतं जे डिस्प्लेसमेंटला प्रपोर्शनल आहे. अशा प्रकारची मोशन ही सिंपल हार्मोनिक मोशन आहे. तर सिंपल हार्मोनिक मोशन ही एक ऑसिलेटरी मोशन आहे ज्याच्यामध्ये फोर्स आणि डिस्प्लेसमेंट अपोजिट आहेत, फोर्स आणि डिस्प्लेसमेंट एकमेकाला प्रपोर्शनल आहेत. लिनियर सिंपल हार्मोनिक मोशन is a linear periodic motion. What is linear periodic motion? Now we will see one by one. Motion is what? Motion is the change of position with respect to surrounding, with respect to time is motion. Oscillatory motion is a type of motion. Harmonic means it is a periodic motion. If it is represented graphically, the graph are similar to that of sine and cosine graph. Therefore, it is periodic and hence it is called as harmonic. And this periodic motion, which is along a straight line, is a simple harmonic motion because the displacement on either side of the equilibrium is same. As the displacement on either side of the equilibrium is same, it is simple. As it is periodic, a function of sine and cosine, it is harmonic, and as it continuously changes its position, it is motion. This simple harmonic motion is a linear periodic. Linear means it is along a given straight line. This linear simple harmonic motion is linear periodic motion in which the force is directly proportional to displacement. How is the displacement? Displacement is from equilibrium, measured from equilibrium. Linear simple harmonic motion is defined as linear periodic motion in which force is always directly proportional to displacement, which is measured from the equilibrium position. And third, which is very important, is that the direction of force is always towards a fixed point, and that fixed point is equilibrium. The linear simple harmonic motion is a linear periodic motion in which the magnitude of the force is directly proportional to displacement measured from the equilibrium, and the direction of force is such that it is always towards a fixed point, and that fixed point is the equilibrium position, as we have seen in the previous parallel spring motion example. Now, all the three things are included in one mathematical equation, that is, in linear simple harmonic motion, the force is directly proportional to minus of x. Therefore, force is equal to minus of k into x, where k is the constant of proportionality, and in magnitude, this constant of proportionality is the force divided by displacement. Therefore, k, the constant of proportionality, which is called as the force constant, is equal to, it is force per unit displacement. This k, force per unit displacement, plays very important role in deciding the period of oscillation of that particle in simple harmonic motion. This is all about linear simple harmonic motion. At the end, I will differentiate the two periodic motions. One is uniform circular motion and other is linear simple harmonic motion. In uniform circular motion, motion is along the circumference of a circle. In linear simple harmonic motion, it is along a straight line. In uniform circular motion, force has a constant magnitude. In linear simple harmonic motion, force has a changing magnitude. It is proportional to the displacement. As the displacement changes, the force changes. This is very important difference between the two periodic motions. In uniform circular motion, the force has constant magnitude. Either it is F is equal to mv square by r, or it is mr omega square, which is a constant. In linear simple harmonic motion, force is equal to minus of kx. It changes with x. And third thing is that in uniform circular motion, the force is always directed towards the center of the circular path. In uniform circular motion, the force is always directed towards a fixed point, that is the equilibrium. मित्रांनो, मला वाटतं एवढं तुम्हाला सगळं लक्षात आलं असेल. मध्ये 11वीचे व्हिडिओ करण्याच्या प्रयत्नामध्ये 12वीचा व्हिडिओ करण्यामध्ये खंड पडला. आता याच्या पुढे मात्र कंटिन्युअसली आठवड्यातून किमान 2 व्हिडिओ तरी मी तुम्हाला पाठवण्याचा प्रयत्न करेन. तर तुम्ही माझं नेहमीचंच म्हणणं आहे की हे व्हिडिओ रिपीटेडली बघा आणि फिजिक्सचा जर्नी आपण खूप एन्जॉयबल करूया. प्रत्येक गोष्ट समजावून घेण्याचा, क्लिअर करण्याचा प्रयत्न करूया. दिस इज ऑल अबाउट द लिनियर सिंपल हार्मोनिक मोशन. फ्रॉम इन द नेक्स्ट video lecture again I will explain few more terms about the linear simple harmonic motion, what are its characteristics of linear simple harmonic motion, and what are the physical quantities involved in circular motion. That all we will see one after the another. Thank you very much. I hope you might have been enjoyed this lecture and used to study the physics regularly through the books, through the video lectures, through your teachers, and enrich yourself by studying more and more about the physics and the concepts of physics. Thank you very much.